Assalamualaikum warahmatullahi wabarakatuh. In this video, we will do tutorial number 1, question 2, December 2018, question from the past year. So now let us read the question. A bracket in the form of plate is fitted to a column by means of 4 rivets. So we have 4 rivets. So N is 4 with the same diameter as shown in figure below. So all of the rivets has same diameter. A load of P is equal to 60 kN is applied to the bracket. So this is our P, 60 kN. The maximum shear stress of the material of rivet is 70 megapascal. So our maximum shear stress for rivet is 70 megapascal. So the question asks to find the centroid of a good rivet. So first, they want us to find the centroid from rivet C. So C will be our reference point. And find the eccentricity. So this is to find E. And then second, find the direct shear and tangential force for each rivet. Okay. So they want us to find the direct shear force and tangential force for each rivet. Last, compute the diameter of the rivet. So last, they want us to find the diameter. So now let's us write all the given data on the right side. So first, to find centroid and eccentricity. So assume centroid x bar and y bar are calculated from reference points rivet C. X bar is equal to summation of area for each rivet times with the x distance from rivet to centroid divided by area for each rivet. So AX times AX plus AB times XB plus AC times XC plus AD times XD divided by total cross-sectional area for all rivet. So rivet for A, area for rivet B, C and D. Since all diameter rivet is same, so area of all rivet is same. So area for rivet A, rivet B, rivet C and rivet D is equal to A, all the same. So X bar, we can take out all the cross-sectional area in the formula. So A times with total XA plus XB plus XC plus XD divided by 4A. So cancel out the A. Next, let's see what is the distance value between all rivet to our reference point C. So from rivet C to D, the length is 60 mm. Then given that from rivet A to D is 150, and then from rivet A to B 90 mm. So we take C as our reference point. So distance from C to rivet A is 150 minus 60, also 90 mm. So we can complete our formula for finding the X bar. So X bar is equal to XA to equal to 0, plus 90 plus 0 plus 90 in terms of the x direction. So divided by 4 rivet. So at the end we will have x bar is equal to 45 millimeter. So now let's find the y bar. So y bar is equal to summation of cross-sectional area for each rivet times with the distance from rivet to our reference point C divided by summation of all area for all rivet. So area for cross-sectional area for rivet A times with the y A, and then for rivet B, and then for rivet C, and for rivet D, divided by the total cross-sectional area for all rivet. So rivet A, B, C, and D. Since all rivet has the same diameter, so we can assume that cross-sectional area for rivet A, B, C, and D is the same. So y bar equal to A YA plus YB plus YC plus YD divided by 4A. So A can be cancelled out. Then let us draw the free body diagram to find the value of YA, YB, YC, and YD. So what is Y? Y is the distance between rivet to our reference points. So this in terms of our reference point is C. So from reference point C to rivet A and B is 90, and then from reference point C to rivet D is 60 millimeter. So y bar is equal to YA is 90, YB is 90, YC 0 because C on the reference point, and then YD is 60 negative because below the reference point C. So divided by 4, so y bar is equal to 30 millimeter. Now we have the centroid coordinate, which is 45, 30. So let us find the direct shear force for each rivet, and then tangential force for rivet A, B, C, and D. So let us draw the configuration of the rivet. So we have 4 rivet A, B, C, and D. So this is the coordinate for our centroid, 45 on the x-axis and then 30 on the y-axis from our reference point rivet C. And then this is our applied load. P is equal to 60 kN acting downwards, and then the eccentricity length or value from applied load to centroid is so 135 minus 45 is 90 millimeter. So that is our eccentricity E value. And then from rivet A to centroid, so the length we assume as RA, and then from centroid to rivet B, RB, centroid to rivet C, RC, and then centroid to rivet D, RD. Then because of applied load acting downwards, so direct shear force on each rivet will be acting upwards, opposite direction with the applied force P acting on downwards. And then because of eccentricity factor, there will be a applied moment acting on centroid MPA. And then because there is a applied moment, so there will be a resisting moment. So resisting moment of rivet A, MA is equal to FTA times with RA. So this is the same with the rivet B. So resisting moment for rivet B is equal to FTB times with RB. And then the direction of the resisting moment opposite with the applied moment. So we also have resisting moment at rivet C. MC is equal to FTC RC And then we also have resisting moment at rivet D, which is FTD times with the RA. And as you can see here, the direction of applied moment is acting clockwise, but the direction of resisting moment is acting anti-clockwise, opposite direction with the applied moment. Okay, then we will determine the direction of tangential force for each rivet. So you can see here, this is the direction of tangential force for rivet A, FTA, and then the direction of FTA must be perpendicular with the RA. Same goes with the tangential force on rivet B, perpendicular to RB, and then the direction of tangential force rivet B must be followed with the direction of resisting moment at rivet B. And all is the same here. So our applied moment value is 60 kilonewton times with the eccentricity value, which is 90 millimeter. So get the value of applied moment is 5.4 kilonewton meter. Next, we will find the value of the distance between all rivet to the centroid, so which is RA, distance from rivet A to centroid, RB, RC and RD. So this is for RA. So there is the rivet A and the centroid. So the distance between rivet A to centroid is RA. And then the length between A to C in terms of X is 45. And then distance between centroid to A is 60 millimeter in terms of Y direction. And then for rivet B, so this is the centroid, and then this is the rivet B. So the length between rivet B and C is RB, and then the length in terms of Y direction is 60 millimeter, and then the length in X axis is 45 millimeter. Then for rivet C, so there is this centroid X, and then this is this centroid C. So the distance between centroid C and C is RC, and then on Y axis is 30, and then distance in terms of X axis is 45. Last is to find RD. So this is the centroid, and then this is the rivet D. So distance between rivet D to centroid is RD. And then the length in terms of y-axis from centroid to rivet D is 90. And then in terms of y-axis from C to centroid is 40. So we can say that RA and RB is the same. So 45 square plus 60 square root. So we get RA and RB is equal to 75 millimeter. And then RC is 45 square plus 32 square root, and then we get 54.083 millimeter. Last is RD, distance between rivet D to centroid is 45 square plus 90 square root, and then we get 100.623 millimeter. So that's our value of R for each rivet. And then the direct shear force, which is V is equal to P over N. P is applied load, N is a number of rivet. So applied load is 60 kilonewton divided by number of rivet is 4. So we get direct shear force acting on each rivet is 15 kilonewton. So now let's write the answer here. Shear force V equal to 15 kilonewton. So now let's find tangential force. So tangential force is equal to moment, applied moment, which is M, times with the R. So R for any rivet, and then summation of distance between rivet to centroid for all rivet, and then square it. Knowing that RA is equal to RB, where both of them is 75mm, RC 54.083mm, RD is 100.623mm. So tangential force at rivet A is equal to applied moment M times with the distance between rivet A and centroid, which is RA, divided by summation of all distance with rivet to centroid, which is RA square, RB square, RC square, and RD square. So tangential force at rivet A is equal to 5.4 power of 3 for applied moment, and then RA is 75mm divided by 75mm for RA, and then 75mm for RB, 54mm for RC, and then last 100.623mm for RD. So FTA is equal to FTB because both of them has the same length of RA and RB. So tangential force for rivet A and B is 16.667 km. Then we can find the others value for tangential force for rivet C and D by using ratio method, which is FTA divided by RA is equal to FTC divided by RC is equal to FTD divided by RD. So FTA is equal to 16.667 kN divided by RA, which is 75mm, is equal to FTC divided by RC, which is 54.083, is equal to FTD divided by RD, which is 100.623mm. So at the end, we can get the value of tangential force for rivet C is 12.019 kilonewton, and then FTD is 22.361 kilonewton. So let us write the answer. So FTA is equal to FTB is equal to 16.667 kilonewton, and then FTC is equal to 12.019 kilonewton, and then FTD is equal to 22.361 kilonewton. Now for rivet A, so this is the configuration of rivet A to centroid, and then between them is the RA, and then this is the direction of FTA, tangential force for rivet A, and then acting outwards is the direction force for rivet A, and then distance between rivet A to centroid in terms of y-axis is 45, and then from rivet A to C in terms of y-axis is 60mm, and then the angle between them is equal to theta 1. So theta 1 can be same as tangent theta 1 equal to 60 over 45, and then theta 1 is equal to 53.13 degree. So from this angle, we can resolve the direction of FTA into X and Y component, but we need to find theta 2 first. So theta 2 is equal to 90 minus theta 1, which is 90 minus 53.13 degree. So at the end, we can get theta 2 is equal to 36.87 degree. So FTA we can resolve into Y and X axis, which is on Y axis acting on downwards. So FTA sin theta 2, and then in terms of X axis acting on the left side is FTA cos theta 2. So resultant force at rivet A is equal to RA. So RAX square plus RAY square, and then both of them is square root. So RA is equal to minus FTA cos theta 2, because acting on the left side, so it minus, and then square it, plus forces on the Y, which is we have direction force VA acting on upwards, and then minus FTA sin theta 2 because acting downwards, so square root. So we put the value, so FTA is equal to minus 16.667 kilonewton times with cos theta 2, which is theta 2 is equal to 36.87 degree, and then square plus VA is equal to 15 kilonewton minus FTA sin theta 2, which is 16.667 kilonewton times with sine 36.87 degree. So square and then square it all. So at the end we get RA is equal to 14.241 kilonewton. Next, for rivet B. So now we draw centroid to rivet B. So distance between rivet B to centroid in terms of Y axis is 60 mm, and then in terms of X axis is 45 mm. And then this is the direction for tangential force for rivet B. And then on rivet B also have the direction force acting upwards, BV. And then between BC to the horizontal line, we assume there is an angle theta 1. So theta 1 we can find from tangent. Theta 1 is equal to 60 divided by 45. So theta 1 is equal to 53.13 degree. So next we will find theta 2. So theta 2 is equal to 90 minus theta 1, which is 90 minus 53.13 degree. So at the end we get theta 2 is equal to 36.87 degree. So the reason why we need to find theta 2 is we want to resolve the FTB into X and Y direction. So in terms of X axis, FTB times with cos theta 2, and then in terms of Y axis, so FTB sin theta 2. So resultant force of rivet B is RB is equal to RB square on X axis, and then RBY square total and square root. So forces on X axis is only one, which is minus FTB cos theta 2, because FTB cos theta 2 acting on the left side, and then we have two forces on Y axis, which is BB acting upwards, so positive, and then we have also FTB sin theta 2 acting upwards, so positive. So we put the value here, so minus 16.667 kilonewtons times with the cos 36.87 degree square plus minus so plus PV, so 15 kilonewton times with plus with 16.6667 kilonewton times with this sine 36.87, so square so at the end we get RB is equal to 28.334 kilonewton. Next, we will find for rebate C. So we draw a free body diagram between rebate C to centroid, and then distance between rebate C to centroid in terms of y-axis is 30 mm. In terms of x-axis is 45 mm. And then this is the direction of tangential force at rebate C. And then this is the direction force or rebate C, BC. And then between them we have theta 1, the angle. So we can find the theta 1 from tangent theta 1 is equal to 30 over 45. At the end we get theta 1 is equal to 33.69 degree. Then we can resolve FTC into two components on x and y. So x is FTC sine theta 1, and in terms of y-axis is FTC cos theta 1. So resultant force at rebate C is equal to RC on X, total force RC on X, and then total force on y-axis. So on x-axis there is only one force, which FTC sine theta 1 square, plus forces on the y-axis we have two, which is VC acting on outwards, and then FTC cos theta 1 acting on downwards, so it is negative. So we put the value here, which is 12.019 kilo times sine 33.69 degree square, plus VC is 15 kilonewton, plus minus 12.019 power of 3 times with cos 33.69 degree square, and then both of them is square root. So at the end we get RC is equal to 8.333 kilonewton. Next is for rebate D. So we draw the diagram between rebate D to centroid, and then the distance between centroid to rebate D in terms of y axis is 90 mm, and then in terms of x-axis is 45 mm. So this is our direction for tangential force at rebate D, FTD, and then there is direction force acting upwards on rebate D, which is VD. So let's assume theta 1 here. So we can find theta 1 from tangent theta 1 is equal to 90 divided by 45. So at the end we get theta 1 is equal to 63.43 degree. So later we can resolve FTD into x and y component. So in terms of x component is FTD sine theta 1, and in terms of y component is FTD cos theta 1. So resultant force at rebate D, so RD is equal to RD x square, which is total forces on x-axis, and then RB is y, so which is total forces on y-axis. So forces on x-axis are only one, which is FTD sine theta 1 square, plus, so forces on y-axis we have 2, so VD acting upwards, and then plus FTD cos theta 1, so square. So we put the value, so FTD is equal to 22.361 kilonewton times VD sine theta 1 is 63.43 degree, plus VD is 15 kilonewton, plus FTD 22.361 kilo times with cos 63.43 degree square, and then square root all of them. So here we get RD is equal to 32.016 kilonewton. So maximum forces acting on rivet when we compare between RA, RB, RC and RD is acting on rivet D, which is RD is equal to 32.016 kilonewton. So last, we can find the maximum diameter for rivet. So we will use the formula of maximum shearing stress, which is equal to maximum force divided by area. So maximum force Fmax is resultant, the most maximum force, resultant force divided by cross-sectional area of rivet, which is pi d square over 4. So simplify, we put pi d square over 4 at the front, so Rmax divided by shear max. So simplify, we can get the diameter is 4 over 5 Rmax divided by shear max. So 4 over 5 Rmax is 32.016 kilo, which is resultant force for rivet D, divided by maximum shearing stress for that material for rivet, which is 70 megapascal. So at the end, we get the value of diameter for rivet is 0.024132 meter, or in millimeter 24.132 millimeter, or 25 millimeter, the nearest one.